Every year, more than 20 million tons of sauce are produced, equivalent to nearly 3 kilograms for every person on the planet, quietly finding their way into almost every meal without us even noticing. No one eats sauce on its own, yet without it, the food industry would lose its key to connecting flavors, and dishes would become disjointed, dry, and monotonous. So how do humans extract and concentrate the essence from raw ingredients into billions of bottles of sauce each year? Today, let's join Agriculture Insight as we step inside the most advanced sauce production lines in the world, exploring how technology transforms agricultural products into liquid seasonings worth billions of dollars, and why they have become almost indispensable in modern human meals. Did you know that one of the most popular sauces in the world was once nearly thrown away because of its unpleasant taste? Officially commercialized in the 19th century, Worcestershire sauce began as a mixture of salted anchovies, vinegar, and herbs. Made from an Indian-inspired recipe but using English ingredients, the initial batch was harsh, pungent, and unbalanced. So much so that it was rejected and stored away in a dark cellar out of sight. But after nearly 2 years of being forgotten, that very process of aging created an unexpected turning point. What was once considered a disaster transformed into a rich, well-balanced sauce, combining sourness, saltiness, and deep umami, becoming an essential highlight in dishes like steak, burgers, and Caesar salad today. The core of this flavor system begins with anchovies that are salted and left to naturally break down over 18 months. During this process, enzymes break proteins into free amino acids, creating a concentrated level of umami that industrial flavor enhancers struggle to replicate. At the same time, onions and garlic are soaked in malt vinegar, a vinegar made from fermented barley, carrying warm, deep notes similar to a light beer. Here, the vinegar not only acts as a preservative, but also functions as an extraction solvent, while softening sulfur compounds and transforming them into more mellow layers of aroma. Once the ingredients have reached their biological maturity, the process moves into a critical stage where the entire flavor system is unified. First, onions and garlic are transferred into large industrial tanks along with salted anchovies, the core components responsible for the sauce's rich natural umami concentration. Next, a system of pumps introduces tamarind extract and molasses, two elements that shape the sauce's bright acidity and deep sweetness while also giving it its characteristic brown color. The mixture is then stirred using industrial agitators at a speed of 15 revolutions per minute, slow enough to preserve the natural structure, yet consistent enough to evenly disperse flavor molecules throughout the entire volume. Within this environment, flavor compounds begin to interact at a molecular level, forming a cohesive structure where everything merges into a deep, rounded, and stable flavor base over time. After 24 to 36 months, the mixture is high-pressure filtered, removing most solids and leaving a clear, dark brown liquid rich in umami that enhances saltiness and prolongs flavor. A standard bottle takes nearly 3 years to develop, yet sells for just $5.8 because the ingredients are cheap, while the real value lies in time and fermentation control. On the flavor spectrum, if Worcestershire sauce is a blended system of flavors, then soy sauce, an apex of microbial control, is created entirely through fermentation. Each year, hundreds of millions of liters are consumed in the United States, yet few realize that behind its popularity lies a tightly controlled microbial ecosystem, where billions of microorganisms transform soybeans into a liquid rich in hundreds of flavor compounds, capable of neutralizing even the strongest odors from meat to seafood. The process begins with raw material preparation, where the difference between premium soy sauce and mass-produced varieties is defined from the very start. Soybeans are carefully selected and steamed under high pressure to break down cell structures and release internal proteins, while wheat is roasted at around 107 to 180 degrees Celsius and then finely ground. This roasting process generates precursor flavor compounds, laying the foundation for the natural amber-brown color and characteristic aroma without the need for any caramel coloring. Immediately after, the mixture is inoculated with Aspergillus oryzae to form koji, the key stage that defines the entire flavor foundation. Within 48 to 72 hours, enzymes break down proteins into umami-rich amino acids while converting starches into sugars, building the base for aroma and aftertaste. Once matured, koji is mixed with brine to form moromi and enters a fermentation phase lasting months to years, where production differences begin to emerge. In Japan, moromi is aged in deep underground pits, where stable temperatures and native microbial communities create complex layers of flavor, with manual stirring to support natural development. In contrast, in the United States, stainless steel tanks tightly control every variable, producing a highly consistent flavor at scale. This fermentation process, lasting from 6 months to 2 years, allows bacteria, yeast, and enzymes to transform the mixture until the flavor reaches a balanced, deep, and stable state. Once fermentation is complete, moromi is spread into layers of filter cloth, folded thick, and stacked in a pressing frame before being subjected to hydraulic pressure of about 2 to 4 bar. After 6 to 12 hours, the first drops of raw soy sauce begin to separate, while the solid residue is retained and compressed between the cloth layers. Although many chefs use soy sauce as a way to reduce salt thanks to its ability to enhance flavor, it still contains around 900 to 1,000 milligrams of sodium per tablespoon. Therefore, only a small amount is needed to boost taste. Overuse can not only throw off the balance of a dish, but also put strain on the cardiovascular system. If soy sauce represents the pinnacle of molecular fermentation, then Doji mustard stands as a testament to the power of instant chemical reactions. Although it is a symbol of French cuisine, the heart of this industry has surged in North America, with Canada supplying up to 80% of the world's mustard seeds. With a global market size of around $2.5 billion, Dijon is positioned as a premium condiment capable of elevating even the simplest dishes with minimal calories. The key difference behind Dijon's reputation lies in its use of unripe grape juice, known as verjuice, instead of regular white vinegar. The natural acidity of green grapes is milder than vinegar, helping to stabilize the pungency while creating a cleaner, more refined finish. The process begins with thoroughly cleaning black mustard seeds to remove all impurities before moving into wet grinding with green grape juice. Here, the friction from grinding not only breaks down the seed structure, but also activates the enzyme myrosinase. This is the critical moment when the enzyme interacts with compounds inside the seeds to release allyl isothiocyanate, the compound responsible for the sharp nose-tingling heat. To preserve these sensitive essential oils, the grinding system is kept below 40 degrees Celsius, preventing degradation from excessive heat. To achieve the smooth texture considered the gold standard, the ground mixture is passed through a high-speed centrifugal filtration system. The intense centrifugal force removes coarse seed husks and fibers, leaving only the finest paste with a natural sheen, without the need for chemical emulsifiers. The final result is a condiment with a uniform structure and sharp pungency, capable of cutting through the richness of grilled meats or serving as the foundation for premium vinaigrettes. Priced at around $5 to $8 per jar, consumers are not just paying for raw ingredients, but for a precise chemical craft that transforms humble mustard seeds from Canadian fields into one of the most powerful condiments on the Western table. And now we arrive at Tabasco, a hot sauce once criticized for being too acidic compared to sriracha, yet it has endured for over 150 years in the global market with just 3 simple ingredients. The journey of each bottle begins with ripe peppers grown on Avery Island. Here, workers use a standardized color stick to match the peppers. Only those with the perfect shade of red are selected, ground, and mixed with sea salt on the same day. At this stage, the most critical and most valuable part of the process is aging. The mixture is packed tightly into white oak barrels and sealed, barrels that were previously used to age bourbon. The most distinctive feature lies in the thick layer of salt spread over the barrel tops, creating a natural one-way valve that allows CO2 to escape while completely preventing oxygen and unwanted bacteria from entering. Over 3 years of natural fermentation, organic compounds in the peppers interact with oak oils, creating layers of complex flavor that no modern machinery can replicate. Once aging is complete, the pepper mash is blended with high-strength distilled vinegar and stirred continuously for 28 days to fully integrate the flavors. At the factory, the sauce is filtered to remove seeds and refined to achieve a uniform texture before being bottled in its signature glass containers. Few people realize that the label is printed in 36 languages, a passport that allows each bottle to enter markets worldwide without changing its identity. With over 160 million bottles exported each year, Tabasco reaches more than 195 countries and territories. But its value goes beyond scale. It has been granted a royal warrant by the British royal family, a rare distinction that reflects not only its global popularity, but also its consistent quality and well-balanced fermentation, combining sharp heat with a signature tangy finish over decades. While many sauces improve with time through fermentation, guacamole is one of the most delicate divas in the world of condiments. After just about 5 minutes of exposure to air, avocados begin to oxidize, turning from vibrant green to dull brown and losing their freshness. So how do you preserve that freshness in a sauce that remains creamy, rich, and slightly tangy, an essential element in dishes like tacos or nachos? It all begins with Hass avocados, known for their high-fat content, smooth texture, and stability, making them ideal for guacamole. These avocados are harvested at the peak of physiological ripeness, when their oil content is optimal, then quickly transported under controlled temperatures to maintain freshness before processing. At the factory, an advanced sensor-based camera system scans every millimeter of the fruit's flesh, removing even the smallest imperfections to ensure the highest possible purity of the raw ingredients. The key lies in the blending stage. By completely forcing oxygen out, the avocado is mixed with onions, chili, and lime juice without triggering any unwanted chemical reactions. The mixture is then immediately sealed into specialized flexible pouches under vacuum, creating a physical barrier that isolates it entirely from the environment. However, the real magic happens in the final step, high-pressure processing. The avocado pouches are placed into a sealed water chamber where pressure is rapidly increased to 6,000 bar. To put that into perspective, this is equivalent to the pressure at a depth of 60 kilometers beneath the ocean, 6 times deeper than the Mariana Trench. At this level, the cell membranes of bacteria, molds, and spoilage enzymes are completely destroyed. Remarkably, because the pressure is applied evenly from all directions and without heat, the chemical bonds responsible for vitamins, color, and the creamy texture of avocado remain intact. The result is guacamole that can retain its fresh, just-picked taste for over 40 days, without the need for any chemical preservatives. First, make sure you clearly distinguish sushi from the many culinary icons that are often confused around the world. Although they are frequently served together, sushi is entirely different from sashimi, slices of fresh seafood served without rice. It is also unrelated to Korean kimbap, where the rice is seasoned with sesame oil and combined with cooked ingredients such as sausage, stir-fried beef, or pickled radish. Amid the wide variety of rolled dishes, the essence of sushi lies in the combination of fresh seafood and the subtle acidity of vinegared rice, the key element that balances the richness of the fish while stimulating the palate, allowing diners to enjoy multiple pieces without feeling overwhelmed. Originating from the ancient method of preserving fish with fermented rice, sushi has evolved into a massive industrial force in Japan. The 4 largest conveyor belt sushi chains alone serve around 5 billion plates per year, generating approximately $15 billion in revenue, far surpassing the scale of the domestic ramen market. Beyond that, in New York, about 60% of meals at high-end dining destinations today are omakase, where diners entrust the chef entirely to deliver sushi at the perfect timing, temperature, and sequence. A single meal can last up to 2 hours, with prices ranging from $300 to $900 per person, reflecting the pinnacle of sushi craftsmanship. At Funka Bay in northern Japan, the fierce waves each December signal the start of the hunt for the most expensive protein on the planet. This is when sea temperatures drop sharply, forcing bluefin tuna to store thick layers of fat to survive, creating a rich, buttery texture that reaches peak economic value. To access these blocks of red gold, Japanese fishermen operate an extremely sophisticated fishing system. First is the single-line handline method, a direct one-on-one confrontation between a person and the fish, the most physically demanding approach, but one that preserves the skin and flesh texture in perfect condition. However, to optimize productivity on an industrial scale, they deploy long-line fishing systems that stretch across the ocean, with each set carrying between 1,000 and 3,000 hooks extending for tens of kilometers beneath the surface. This method is preferred because each circular hook is designed to automatically lock into the corner of the fish's mouth, keeping the ocean giant secure without tearing the valuable flesh inside. Every fish, once brought to the surface, must be gutted, have its neural signals eliminated, and then be immediately chilled with ice. Otherwise, extreme stress will cause lactic acid to build up, burning the flesh from within and turning the ruby red meat into a mushy, sour mass. A delay of just a few minutes can cause a tuna weighing over 200 kilograms to instantly become worthless, fit only for animal feed. From offshore fishing fleets, each tuna is hoisted by container cranes directly into the world's largest fish market, Toyosu Market, a hub that gathers hundreds of dealers and circulates about $12.5 million worth of seafood every day. Here, the early morning atmosphere becomes the focal point, with thousands of tuna arriving from around the world, from locally caught fish to massive specimens transported all the way from Ireland. The entire auction floor is painted a distinctive green, a clever visual trick that makes the ruby red color of tuna meat appear more vivid and striking under the lights. Before the auction bell rings to signal the start of the hunt, professional buyers carry out inspections using a tool called a sashikage. They extract a small sample from the tail, examine it under a flashlight to check the color, and may even touch or taste it to evaluate fat content and elasticity. Once the auction officially begins, the atmosphere becomes intensely tense with the rapid-fire chants of the auctioneer. All transactions take place at lightning speed using the Tayari hand sign system, a form of body language that allows them to count up to 100 using only finger movements. A single mistaken gesture or misread signal can cost a buyer dearly, either by paying for an unwanted lot or losing the chance to secure a prized catch to a competitor. Each buyer has only about 10 to 15 seconds to make a final decision, and once a fish is sold, absolutely no one is allowed to touch it. The pinnacle of this luxury was once again set at the first auction of the year. A 243-kilogram bluefin tuna, caught in the renowned waters of Oma, was sold for an all-time record price of $3.25 million. The buyer was none other than Kiyoshi Kimura, the tuna king and owner of the Sushi Zanmai chain. From here, the finest bluefin tuna are transported directly to high-end restaurants in ice-packed conditions. But before the massive fish is placed on the cutting table, one of the most important preparatory rituals begins. Knife sharpening is not merely maintenance. It is an art that demands absolute patience and precision. Master shokunin use a range of whetstones with varying grits, from coarse to ultrafine, even reaching 10,000 grit or higher. This process can take hours, until the 1.5-meter-long Maguro Bocho blade achieves the sharpness of a samurai sword, capable of slicing a sheet of paper suspended in mid-air without applying any pressure. With a blade sharpened to near liquid precision, the butchering ritual takes place on a damp surface to eliminate friction, allowing the craftsman to maneuver a fish weighing hundreds of kilograms with remarkable smoothness. The process does not begin with cutting the flesh, but with controlling what can destroy it the fastest: enzymes from the internal organs. Therefore, the first step is always to open the gills and abdominal cavity, completely removing the internal organs to halt decomposition immediately. Once the body is stabilized, the fins and head are processed to eliminate any obstacles, clearing the path for the blade to move precisely along the spine. Only then does the dorsal cut begin, requiring a perfectly straight and continuous stroke. Even the slightest deviation can damage the muscle fibers, instantly wiping out thousands of dollars in value from the fish. Finally, the cuts of meat are separated from the bones, and the thick skin is removed along the grain to preserve the integrity of the precious fat layers. The entire portion is then tightly wrapped in specialized cloth and rapidly chilled before entering the aging stage, where endogenous enzymes transform proteins, eliminate sourness, and activate umami, the key element that creates deep sweetness and a velvety texture. From these perfectly matured cuts, the journey of transforming tuna into melt-in-your-mouth slices enters its most refined stage upon arriving at the restaurant. Here, the art of saku begins as shokunin break down the massive blocks into precise rectangular portions, ensuring not a single millimeter of meat is wasted before the decisive cuts are made. A fundamental rule every itamae must remember is to cut against the grain to break down muscle fibers. This is the key that allows the fish to instantly release its flavor and melt upon contact with the warmth of the mouth. Unlike sashimi, which is often cut thicker to emphasize a firm, chewy texture, tuna prepared for sushi is sliced thinner and longer to create a soft drape that gently embraces the rice. In fact, if you order a typical tuna sushi plate, most of what you are eating is chutoro, the belly cut that makes up about 20% of the fish's body, offering an almost perfect balance between the richness of fat and the sweetness of lean meat. The most prized item on the menu is otoro, the lower belly cut that accounts for less than 5% of the fish, with dense marbling where the highest energy is stored. Interestingly, otoro was once considered cat food because it was too fatty and spoiled quickly, but it has now become a symbol of luxury, with prices reaching up to $80 for a single piece of nigiri. In contrast, akami, The deep red meat along the spine makes up about 60% of the entire fish and carries the purest flavor along with the highest iron content. However, precisely because it is lean, akami is also the most difficult part to handle. Even the slightest mistake can immediately reveal a fishy taste and dryness. For this reason, true connoisseurs judge a chef's skill not by otoro, but by how well they prepare akami to achieve a smooth texture and a clean, pure umami sweetness. But would you believe that those million-dollar cuts of tuna are merely the foundation? The true soul of sushi lies in the shari, sushi rice, the element that determines up to 80% of the quality of a perfect piece. In reality, premium seafood can be bought with money, but the technique of preparing the rice is the ultimate standard that separates a master from the rest. It all begins with selecting short-grain rice with a high amylopectin content, the type of starch that provides stickiness and cohesion, while still allowing each grain to remain distinct in the mouth. Once cooked, the rice is not left to cool naturally, but is immediately transferred into a hinoki wooden tub, a material capable of controlled moisture absorption, removing excess steam without drying out the core of each grain. At this stage, the mixing of red vinegar akazu takes place while the rice is still warm. Unlike regular white vinegar, akazu has a deeper acidity and a rich umami finish, key elements that not only balance the fattiness of the fish, but also define the entire flavor foundation of the sushi. But most importantly, the secret of great sushi lies in temperature. A professional itamae always keeps the rice at around 37 degrees Celsius, close to human body temperature, allowing the fish's fat to soften instantly upon contact without compromising the structure of the rice. In other words, sushi is not a random combination of rice and fish. It is a system of precise control over temperature, moisture, and structure. That's why you should never dip the rice side into soy sauce. A proper piece of sushi has already been perfectly balanced in every aspect, so the only thing you need to do is place the whole piece in your mouth and experience the complete harmony of temperature, acidity, and richness. However, sushi has not always been globally popular in its original form. When it entered the American market in the 1960s, it faced a very practical barrier. Most Americans were not ready to eat raw fish, and were even less comfortable with the black seaweed wrapped on the outside. To adapt, the California roll was created in Los Angeles as a simple yet highly effective solution. By turning the rice to the outside to hide the seaweed and replacing raw fish with avocado and imitation crab, pioneering chefs opened the door for sushi to enter the American mainstream. As a result, from a once unfamiliar dish, sushi quickly grew into a multi-billion-dollar industry with more than 16,000 restaurants across the United States. So much so that in 2007, Japan officially recognized the California roll as a legitimate form of sushi, completely removing the stigma of it being a fusion dish. Ultimately, whether you are sitting at a casual conveyor belt restaurant or spending hundreds of dollars on an omakase experience in Manhattan, the essence of sushi remains unchanged. It is the absolute precision of ingredients, structure, and timing, all working together to transform fresh seafood into a refined culinary experience. Plant-based meat officially broke into popular culture in 2019, when Beyond Meat and Impossible Foods simultaneously pushed plant-based burgers beyond the vegetarian niche, placing them in direct competition with beef on supermarket shelves and in major fast food chains. In a short time, what had been a niche alternative was shaped into an entirely new industry. Beyond Meat targeted consumers who still enjoy eating meat, with burgers made from pea protein, promising to reduce dependence on animal farming without forcing people to change their eating habits. Meanwhile, Impossible Foods chose a faster and broader path, partnering with Burger King. The Impossible Whopper, made with soy protein, generated over $100 million in just 4 months, becoming one of the most successful product launches in the history of American fast food. But the excitement did not last long. Shortly after Beyond Meat reached a peak market capitalization of nearly $14 billion USD, the US plant-based meat market began to stall and then decline. Consumers shifted from curiosity to skepticism. Despite having protein levels comparable to beef, plant-based meat is a highly processed product, often containing high sodium levels and an ever-growing list of ingredients. The paradox lies here. In supermarkets, a single Beyond Burger still costs more than $2 nearly twice the price of a standard frozen beef burger. So what exactly in the production process has driven the cost of plant-based meat to this level? And who is really paying that price? For technology, for the environment, or for consumer expectations themselves? The journey of plant-based meat, often described as a solution to reduce the environmental burden on the planet, actually begins with something remarkably small: soybeans. From late September through November, soybean fields stretching across the American Midwest enter peak harvest season. More than 70% of today's plant-based meat products rely on soybeans, not by chance, but because of their exceptional water-holding capacity and fiber-binding properties, which create the closest chew and fibrous pull to real meat. To preserve these characteristics, soybeans must be harvested at a precise biological window. The plant has dried, while the beans retain approximately 15% moisture. Harvest too early, and the proteins are not yet stable. Harvest too late, and the beans crack easily, losing their ability to bind and form structure. When harvesting begins, headers nearly 12 meters wide are lowered close to the ground to collect pods growing low near the base of the plant, where nearly all yield is concentrated. Inside the machine, threshing drums, sieve systems, and air fans separate the pods while keeping the beans intact. Meanwhile, dry stems and leaves are returned to the field, forming a biological mulch layer that protects the rich mollisol soils beneath. Each hectare can yield around 4 tons of soybeans, but for the plant protein industry, only batches with at least 95% intact beans are accepted. Cracked beans, though still edible, have lost their ability to form fibers and gels, making them unsuitable for replicating the structure of real muscle tissue. These stringent requirements mean that the plant protein supply chain cannot rely on a single crop alone. To create a light-colored protein base with a neutral aroma and lower allergenic potential, the industry also turns to peas. Unlike soybeans, peas used for protein extraction are harvested while the plants are still green, when the seeds have reached full size but before starch conversion begins. This requires an entirely different type of machinery, the pea viner, a machine designed to separate fresh peas rather than cut and thresh dried crops like conventional harvesters. At the front, gathering reels pull in the entire plant and feed it directly into the machine. An in-feed elevator lifts the full vines into the separation chamber, where high-speed but low-impact beaters open the pods, allowing the peas to fall free without being crushed. The material stream then passes through a rotating screening drum, continuously sorting between acceptable peas and remaining plant matter. Clean peas are transferred into a sealed onboard hopper, preventing contamination and minimizing mechanical damage during transport. Operating in a continuous cycle, each pea viner can process approximately 3 hectares per hour, supplying a steady stream of raw material to protein isolation facilities. From this moment onward, the quality of plant-based meat is already determined in the field, long before any downstream technology intervenes. The process begins by blending plant proteins with liquid fats. Isolated and dried legume proteins are fed into sealed mixing vessels, where they are combined with water, vegetable oils, and emulsifiers to recreate the fat content and water-holding capacity of meat. Within minutes, the proteins become fully hydrated, forming a moist, pliable mass. Under high torque, protein chains are forced to realign in the same direction, creating fibrous structures that produce the tear and chew associated with meat. Among them, soy protein provides more stable chewiness, while pea protein offers a milder aroma but a softer structure. However, texture alone is not enough. To generate aroma and flavor during cooking, leg hemoglobin, a heme source naturally found in legume root nodules, is fermented, filtered, and concentrated into a dark red solution, then added to the protein matrix. This compound triggers the Maillard reaction, producing savory aromas, umami flavor, and a brown seared crust when exposed to heat, while beet-derived pigments serve only to enhance the red color in the raw state. Once the meat matrix reaches sufficient plasticity and cohesion, the entire mixture is fed directly into an automated forming system. The soft mass is continuously extruded and precisely cut to preset dimensions, ensuring that every piece leaving the machine is identical in thickness and structure. Round shapes are used for burgers as they fit perfectly with sandwich buns. Rectangular forms are chosen for sandwich patties and ready-to-eat meals, thanks to their ease of stacking and precise portion control on industrial production lines. Immediately afterward, each patty is automatically placed into trays, sealed, chilled, and packed into cartons. From this point on, plant-based meat becomes a fully standardized product, ready for global distribution by manufacturers in the United States and Europe. On a separate production line, raw plant-based meat is also fed into structure testing and compression forming systems. Pressure and compression forces are carefully calibrated to replicate the thickness, elasticity, and cooked state behavior of real beef burgers before packaging. Once taken off supermarket shelves, plant-based meat is cooked almost exactly like traditional ground meat, but in reality, it is far easier to control during cooking. Anyone can become a home cook with a single pack of plant-based meat pulled from the refrigerator. Because the proteins have already been processed and stabilized in the factory, the mixture shrinks less, retains moisture better, and does not require precise timing for rare or medium doneness. This makes it especially well suited for quick pan searing and burger forming. With just 2 to 3 minutes of direct contact with a hot pan, the patty rapidly develops a brown crust and familiar savory aroma, while the interior remains evenly moist. For many American households, this is a clear advantage. Pre-packaged plant-based meat delivers consistent results, even when the cook has limited time or experience. At a professional scale, this advantage becomes even more pronounced. In fast casual chains, modern burger restaurants, and experimental kitchens run by young chefs, plant-based meat is often treated as a neutral protein base, lightly seasoned, pan-seared, or pressed flat to fine-tune bite texture. Thanks to its uniform structure, each batch produces nearly identical size, doneness, and cooking time, allowing restaurants to operate smoothly even during peak hours. Notably, frozen plant-based meat typically has a shelf life of 6 to 9 months, giving restaurants far greater inventory flexibility and significantly reduced waste compared to fresh meat. We rarely stop to think about this, but the number of livestock animals now exceeds the human population by 4 times, and the total biomass of animals raised for meat is nearly 10 times greater than that of all wild mammals combined. From an environmental perspective, industrial livestock farming accounts for around 14% of global greenhouse gas emissions, roughly equal to or even slightly higher than the entire transportation sector. In other words, in terms of emissions, the piece of beef on your plate carries a greenhouse footprint comparable to that of a vast transportation system operating every day. Few people know that Chef Boyardee ravioli was born as a pivotal twist that helped spaghetti enter industrial-scale production. As urban populations surged, the pressure to feed sprawling metropolises increased, and the demand for durable, transportable food that still maintained quality became a standard from the 20th century onward. But unlike any traditional long spaghetti, Chef Boyardee conquered the mass market while taking a distinct approach. Using square pillow-shaped ravioli allowed the soft pasta to fully encase the meat and sauce, making each portion compact enough to fit in a can and easy to eat directly with just a spoon. To this day, billions of cans of Chef Boyardee are produced each year, carrying the smiling face of Ettore Hector Boyardee, who personally oversaw the recipes and production process for nearly 20 years before passing the brand to American Home Foods. This journey began with a simple observation at his restaurant. The number of customers buying sauce to take home far exceeded those dining in, revealing a demand for flexible eating beyond the traditional dining table. Amid the cracked savannas of Namibia, a black rhino weighing over 1.2 tons hangs upside down beneath a helicopter. The sight may seem absurd, but it is, in fact, the safest wildlife transport technique in the world. Every journey like this begins with one mission: to rescue, protect, and return life to the wild. Before the flight, conservation workers sedate the rhino, check its health, attach a tracking device, and secure straps around its ankles, the strongest and safest load-bearing points. The upside-down position allows it to breathe more easily, maintain steady circulation, and avoid injury throughout the flight. Each relocation costs tens of thousands of dollars and mobilizes veterinarians, pilots, and rangers, all for the sake of giving one life another chance to live. When the helicopter lands, the rhino is carefully lowered to the ground, revived from anesthesia, and awakens in a safe haven, where hope begins again. The entire process lasts only 15 to 20 minutes, yet each flight is a test between life and death. Across Africa, fewer than 6,000 black rhinos remain, and sometimes to save just one, an entire fleet of helicopters must take to the skies. To compete on racetracks across the globe, more than 30,000 racehorses each year must take to the skies, becoming the most extraordinary passengers of the global logistics industry, where every movement is precisely calculated to ensure absolute safety. Before takeoff, each horse undergoes a full health check, vaccination, and receives an international quarantine certificate. They are then guided into air stables, specialized transport containers equipped with non-slip floors, soft partitions, and stable temperature control systems. Each compartment typically holds 2 to 3 horses, carefully secured before being lifted onto the aircraft by a specialized loader. Throughout the flight, a groom, an onboard caretaker, travels with them to monitor, comfort, and make sure the horses remain calm and well-fed. The cargo cabin maintains a quiet environment with controlled pressure and temperature, helping minimize stress during the entire journey. Upon landing, the horses are taken directly to a veterinary quarantine facility for a final health inspection before continuing to racetracks or training centers. It may seem like just another logistical operation, but behind it lies dedication, precision, and profound respect for these extraordinary creatures. The transportation of live livestock is a crucial link in the global agricultural trade, enabling cattle and sheep to reach markets for consumption or breeding. The primary goal is to ensure their safety and welfare throughout journeys that often span thousands of kilometers. The process begins on farms, where animals undergo health checks, vaccinations, and receive identification tags to guarantee full traceability. They are then loaded onto multi-deck specialized trucks equipped with ventilation systems and non-slip floors, all designed to minimize stress during transit. Upon arrival at the port, the livestock are taken to the export holding area to rest, eat, drink, and undergo a final health inspection. Next, the livestock are guided up safe loading ramps onto vessels under the supervision of technicians and veterinarians. On board, they are housed in pens fitted with water troughs, forced ventilation, and bedding, with 24-hour monitoring to safeguard their health. Feed and water are provided continuously throughout the voyage, which can last from several days to several weeks, depending on the destination. Although animal welfare standards such as LGAP have been introduced, the transport of live animals still carries significant risks. Long journeys can cause stress, dehydration, or heat shock. Yet, every improvement in this process represents a step forward toward a more humane and sustainable future for live animal transport. Just like the transport of livestock demands absolute precision and safety, helicopter training for canine units is a form of specialized logistics, where every detail is carefully calculated to protect the lives of these four-legged partners. Canine warriors from military and special police forces are trained for rescue missions, criminal pursuit, and operations in rugged terrains, where helicopters are often the only way to reach the field. They are conditioned to become familiar with the roar of rotor blades, the scent of aviation fuel, and to stay calm under intense pressure. During flights, each canine is equipped with a heavy-duty harness featuring a 5-point locking system, stainless steel connectors, protective goggles, and noise-reducing ear covers, ensuring balance and orientation amid the powerful noise of the helicopter. Most training flights are conducted in tandem position, with the dog and handler suspended together beneath the aircraft, allowing the trainer to monitor breathing, movements, and reactions throughout the flight. On average, a canine requires 15 to 30 flight sessions to become fully mission-ready. Calm when approaching rotors, steady while hanging in mid-air, and ready to act within seconds after landing. It's more than just a test of skill. It's a testament to the unbreakable bond between humans and their most loyal companions. Once the most basic means of animal transport, pig trucks have now evolved into mobile barns, where pigs receive measured feed, clean water, continuous health monitoring through sensors, and human care throughout the journey. From a strictly sanitized loading area, the herd walks up non-slip ramps into insulated metal compartments lined with dry straw, clean water systems, and 24/7 gas sensors. Just a single speck of dust slipping through the filtration system, if carrying the ASF virus, African swine fever, which can survive for months in frozen meat, is enough to wipe out an entire farm and disrupt the global pork supply chain. That's why the air circulating inside these trucks isn't just a breeze. It's the fragile boundary between a safe journey and a silent pandemic. With the massive scale of Texas's livestock industry, only these 25-meter-long livestock trucks are powerful enough to carry nearly 200 cattle across thousands of kilometers. Each convoy consists of 2 or 3 double-deck trailers, connected to the barn by steel ramps inclined at less than 20 degrees, allowing the cattle to walk up naturally without force. Handlers use paddle sticks, tools that emit light and sound signals, instead of electric prods, guiding the herd in a humane yet highly effective way. Throughout the journey, the cattle travel in well-ventilated compartments, aluminum bodies perforated for airflow, insulated roofs, draining floors, and continuous temperature sensors that prevent heat stress and dehydration, even under the scorching Texas sun. Compared to standard trucks, these vehicles are heavier and more expensive, yet they cut transport losses by more than half, ensuring a seamless global beef supply chain, where every steak that reaches the table remains fresh, tender, and world-class.